Hello everyone, this is INE Foundation Lab 2, section 6.1 IPv4 over DMVPN. Okay, before I configure this section, let me explain some DMVPN topics and I will come back and configure this section. Okay, as we know, we have three DMVPN phases. One is DMVPN phase 1, phase 2 and phase 3. DMVPN uses following protocols. It is consists of multiple protocols. One is multi-point GRE, MGRE, NHRP or Next Hop Resolution Protocol. Routing, it uses RIP, ERGRP, OSPF, BGP, and etc. And if we want security, we can use IPsec. It is not mandatory, but if we want, we can use IPsec either. The DMVPN phase 1. It uses NHRP. In the DMVPN phase 1, spokes register themselves with the hub. Hub is using multi-point GRE interface, but not the spoke. For this reason, in the DMVPN phase 1 configuration, I will explain this configuration later in details. For this reason, for the DMVPN phase 1 configuration, we used tunnel mode GRE because it is using tunnel GRE. In the DMVPN phase 1, spokes are using point-to-point GRE tunnel interfaces. And on a spoke, we use tunnel destination address. The tunnel destination address, the IP address. And we don't have direct spoke-to-spoke communications. All traffic has to go to hub. For routing configuration, spoke router only needs a summary or default route to the hub to reach other spoke routers. DMVPN phase 2. Hub is using a multi-point GRE interface. In phase 2 configuration on hubs, we use tunnel mode GRE. All the spoke routers use multi-point GRE headers. For this reason, we are on the spokes. We have tunnel mode GRE configuration. Tunnel mode GRE command. And spoke router will reach another spoke by sending NHRP resolution request to the hub to find the MBMA IP address of the other spoke. And spoke router need specific route. On the DMVPN phase spokes need specific routes. And the common to make spoke-to-spoke communication are these two. We have two requirements for spoke-to-spoke communication. One is spoke routers need to have a route for the network that they are trying to reach. On a spoke, we have to have route for that for other spoke that they are trying to reach. And the next hub IP address after route has to be the remote spoke. Next hub IP address has to, for that route of that route has to be remote spoke. This is two requirements for spoke-to-spoke communication in the DMVPN phase 2. And routing configuration, summarization on hub is not possible since spoke router requires specific routes. Because spoke router need to have specific route, summarization on the hub in the DMVPN phase 2 is not possible. DMVPN phase 3. In the DMVPN phase 3, spoke router do not need specific route like the DMVPN phase 2, and it doesn't matter what the next hub IP address of that route has to be. In the DMVPN phase 2, we don't have these two requirements for spoke-to-spoke communication. It doesn't matter what the next IP address of, of the root has to be. In the phase 2, for spoke-to-spoke communication, spokes send traffic to the hub, then hub use NHRP redirect to the spoke. Because hub is using NHRP redirect to the spoke, in the DMVPN phase 3 configuration, we have NHRP redirect command on hubs, and then spoke use NHRP resolution to install that route. And on a spoke we have NHRP shortcut command for the phase 3 configuration. Okay, let's explain the DMVPN phase 1, phase 2, and phase 3 configuration. Okay, this is one important to notice to understand. For NHRP configuration in all of these phases, phase 1, phase 2, and phase 3, on hub we have the same. We have NHRP multicast dynamic for hub, but on a spoke for NHRP configuration, we can use either take commands or we can use single command for spokes. For NHRP configuration on the spokes, we can use either this take command or this command. This is important to understand. I will explain this after with the DMVPN configuration. Okay, for the DMVPN phase 1 configuration, for hub we create our interface tunnel or tunnel name. Then we specify IP address, its own IP address. Our tunnel source, this is our MBMA physical interface, its own IP address. Then NHRP authentication, NHRP network ID, and tunnel key. And we have NHRP map multicast dynamic command on hub and tunnel mode GIE multiple. This is the DMVPN phase 1 hub configuration. And for spoke, we specify tunnel name, IP address after tunnel, this one IP address. Tunnel source, this is MBMA interface IP address, this is IP address. NHRP authentication, network ID, and tunnel key. As I explained before, for NHRP configuration on spokes, we have three commands. For NHRP map multicast, for map we always use MBMA or physical IP address. For NHRP map multicast, we use MBMA physical interface IP address of hub. This is hub address. Then NHRP NHS or tunnel IP address of the hub. This is the tunnel IP address. And NHRP map without multicast, NHRP map. For NHRP map without multicast, we use two IP addresses. One is NHRP tunnel IP address of the hub, then MBMA physical IP address of the hub. For NHRP map, we use two IP addresses. One is for one is a tunnel, the other one is physical MBMA address of the hub. Then for DMVPN phase 1, we have tunnel destination and MBMA physical IP address of the hub. For DMVPN phase 2, it is the same as phase 1. Let's configure this. Instead of tunnel destination, we use tunnel mode GIE. Let's review quick. We use the interface tunnel name, IP address of tunnel, its own IP address, tunnel source, then we use MBMA physical interface address, NHRP authentication, network ID, and tunnel key. On hub, we use NHRP map multicast dynamic and tunnel mode GIE multiple. On the spokes, we create tunnel name, IP address of the tunnel, its IP address. Tunnel source is physical address, its own IP address. NHRP authentication, network ID, tunnel key. And for spoke, we have take command for NHRP. NHRP map multicast, Then we use NBM over physical IP address, NHRP NHS. Then we use NHS or tunnel IP address of hub, and IP NHRP map. And we use two IP addresses. One is NHS tunnel address of hub, and the other one is NBM over physical IP address of hub. And for export, we use tunnel mode GRU in the DMVPN phase 2. In the DMVPN phase 3, this is the same as the DMVPN phase 2, plus we have these two commands: IP NHRP redirect for hub and IP NHRP shortcut for export. For hub, we create interface, tunnel name, IP address of tunnel, tunnel mode GRU motor point, tunnel source NBM physical address of tunnel, in authentication network the tunnel key. We use IP NHRP map modcast dynamic and IP NHRP redirect on hubs. And on a spoke, we create tunnel, IP address of tunnel, tunnel mode GRU, tunnel source, and specify NBM physical interface address. And then NHRP authentication network the tunnel key, and we use our three NHRP commands: IP NHRP map multicast, and specify NBM or physical address of hub, IP NHRP NHS, then specify NHS or tunnel address of hub, IP NHRP map, then we specify two IP addresses. One is tunnel and the other physical address of hub. And we use IP NHRP shortcut for spokes. Okay, as I explained before, we can configure NHRP either by three commands on the spokes or single command. The single command is this one: IP NHRP NHS, then specify NHS or tunnel address of hub, then we use NBMA command, then we use NBMA physical address of the hub, then we specify multicast at the end. This command is the same as all these three commands for NHRP configuration. Okay. We have one design. This is FVRF DMVPN. We are not gonna use this FVRF, but I want to explain what this is. Okay, first we have to understand what is recursive routing error. This error, tunnel 5 rect down, tunnel 0 temporary disability to recursive routing error. This message is recursive routing error. It means that generic routing encapsulation or generic tunnel router has discovered a recursive routing problem. It causes the router to try to route to the tunnel destination address using the tunnel interface itself. It causes the router to try to route to the tunnel destination address using its tunnel interface itself. This is what we call recursive routing error. Fernando VRF. Fernando VRF is the logical separating of underlay or transport network and overlay or tunnel network by VRF. It is being to solve recursive routing problem, this problem. And for VRF configuration, it is just simple. First we create VRF. For creating VRF, we use VRF different command, VRF name, and we specify RD if we want. Then address family, IPv4, and it is other address file. This creating first we create VRF. And this is important to put. Then we put our physical interface of hub and spokes into VRF by VRF forwarding. This is the physical interface. We put our physical interface, physical interface. Then we use VRF forwarding, our VRF name. Then we put our IP address. Then we put our physical interface of hub and spokes into VRF. Then we modify our underlay network. For OSPF we use Auto OSPF VRF. Then we modify our transport into VRF and leave the tunnel interface on our routers in the global routing table. We don't put our tunnel interface into VRF by tunnel VRF name command. This tunnel VRF name on the tunnel configuration, it tells tunnel interface to use the underlying routing in VRF table rather than global routing table. In front of VRF configuration, we don't move our tunnel into VRF while VRF forwarding. We simply use tunnel VRF command. Okay, this is front of VRF configuration, but we are not going to configure front of VRF in our scenario. I just want to explain what is front of VRF. This for solving recursive request problem. Okay, let's configure this section. Let me pause. Okay. This one. Configure DMVPN between R1, R7 and R8. We have to configure between 1, 7 and 8. R7 is the hub and should have two distinct DMVPN networks, one toward R1 and the other toward R8. Okay, this should blue, red, black. R7 is our hub, and it should have two networks, two DMVPN network. One is toward R1. Let's make this is also tunnel. This is tunnel. We have one tunnel 17 on our hub, one tunnel 7 on hub, and tunnel 17 on spoke. This is R1. Then we have another network, DMVPN network, toward R8. This is spoke. I have tunnel 17.8 on R7 and tunnel 78 on router R8. On R7 I have two tunnel interfaces. On R1 and R8 I have one tunnel. One is tunnel 17 on R1 and tunnel 78 on R8. So two different DMVPN. 7 and 1 and R8 are spokes. This is our spoke. The spoke and hub. Okay. I will use the DMVPN phase 2 here. Phase 2. To separate the underlay network from overlay network, create a VRF colored DMVPN. Okay, we have to create one VRF colored DMVPN on each router and place DMVPN tunnel into this VRF. Okay, here we have to create we have to move our DMVPN tunnels into VRF by VRF forwarding for on the tunnel interface. But for under VRF, we don't move our tunnel into VRF. We leave our tunnel into VRF, and we leave our tunnel, but we simply type tunnel VRF under our tunnel command. This is the for under VRF configuration. But here, I have to move our tunnel into VRF for separating on the overlay network. This is another design. And use the IP address of this for R1 or 7 DMVPN. Another IP address of this is 17 and 17 on third octet. For R7 and R8 DMVPN addresses, where 8 is hotel number. Okay, then we have to use authentication private. Use tunnel key 17, network ID 17, and for the two different 17 for 7 R1 and 78 for router 7 and 8. Okay, you may use a single static route on R7 to ensure that it has reachability to tunnel endpoints. R7 should not form routing protocol adjacency with R7. Okay, we don't have to configure routing protocol between R5 and R7. We simply use a static route on R7. Okay, let's configure. This is the phase 2 configuration. Well, let's start by hub R7. Okay, because I have to place the DMVPN tunnel into VRF, so let me first create VRF and move our tunnel into VRF, then I'll specify IP address. Okay, let's start creating VRF on R7. VRF definition. I have to use DMVPN. We have called DMVPN. DMVPN. Then I specify RD. This is 7. This is address and NN. It would distinguisher. Then specify address family, IPv4, unicast, and exit. This is our VRF configuration. And specify our tunnel. Okay, I'll go up to settings. To show VRF, I have DMVPN. We have DMVPN. Still no interface for this VRF, and this is with distinguishing 77. Okay, let's create a DMVPN interface. Tunnel 17. And for the DMVPN phase 2 configuration, then I specify IP. Okay, before I specify IP address, I have to forward this into VRF. Let's press VRF forwarding then DMVPN, and then if I do show VRF, now I have tunnel 17 into our DMVPN. Okay, then I have to specify IP address of tunnel. IP address 156 192 17, and this is hotel 7. This should be 7 and 255 255 that's 0. Okay, then I have to specify authentication. Let me authentication key is private. NHRP authentication is private. Okay. Then network ID is 17. This we have to use tunnel key and network ID 17 for this. Okay, IP NHRP network ID and tunnel key. IP NHRP network ID 70 and tunnel key 70. Okay, and tunnel source. This is a physical MBMO physical IP address. Okay, let's do show IP interface brief. This is tunnel source. This interface. Then it should be tunnel source. Tunnel source. This net. Okay, I have specified tunnel source. I specified IP address, tunnel authentication, network ID. And because it is hub, I have to use IP NHRP map multicast dynamic. IP NHRP map multicast. This command is for hubs. And tunnel mode GI multiple. Tunnel mode GI multiple. Okay, this is of hub configuration. Do show run I have created VRF. I have more forwarded this VRF. I have specified IP address, and this is hub. I have tunnel mode and IP multicast dynamic for hub. Okay, let's configure its spoke. The spokes are one. First, create VRF definition, DMVPN. I specify with distinguisher. I can let's put this one, and add this family IPv4 unicast. Let's specify this. Do show VRF. Then create our tunnel interface tunnel 17 and move this tunnel into VRF. VRF forwarding the name of DMVPN. This is DMVPN. Name of VRF to show VRF. It is going. This is tunnel 1. Then specify IP address. IP address is 192.171 and /24. Okay, then I have to split tunnel source. Let's do show IP interface brief. On tunnel, use this one. Tunnel source. This tunnel. Then IP authentication. IP NHRP authentication is private. Then open the network ID. IP NHRP network ID is 17 and tunnel key is 17 either. And I have to, because it is the DMVPN phase 2, I don't have tunnel destination, instead I have tunnel mode GIE. Let's specify tunnel mode GIE multipoint. And I have to specify NHRP commands on the spoke. First is IPNHP map multicast. IPNHRP. Okay, let me Let me use single command instead of three commands. Okay, let me use this single command on a spoke. I will use this single command for NHRP configuration on spoke. I will use an IP NHRP NHS. Then I have to use tunnel address of hub, tunnel address, this is our tunnel address. Then I have to use NBMA, then NBMA physical address of hub. This is this IP address of this interface tunnel source. NBMA. Okay, do show IP interface brief. This address is this one, 156.156. This address of tunnel source. I read here. This NBMA address of hub. Then I use multicast at the end. Okay, if I use this single command, I don't have you take this three. I only use this three. This is NHRP on NHRP configuration on spoke. Okay, let's configure our second urban spoke. On our 7, I have to create another tunnel. Interface tunnel 78 FVRF forwarding DMVPN IP address 156 192 787 and this subnet mask. Then we're gonna have to use IP. This is hub. IP NHRP authentication is authentication is private. IP NHRP network ID is 17 this time, and IP NHRP key is tunnel key, and tunnel key is 78 either. and because it is hub, I have to use IP NHRP map multicast dynamic, and tunnel mode is GIU multipoint. And I have to put tunnel source to show IP interface brief. Tunnel source is this one, 57. Tunnel source, this one. That's it. This is hub. Let's configure spoke. Config T VRF definition DMVPN root distinction is 8.8 and address family IPv4 for unicast. Exit. Create a tunnel interface. Tunnel 78 VRF forwarding DMVPN. Do show VRF is using to DMVPN. IP address is 156 192 78 and 8. IP NHRP authentication is private. Where's this is 31. IP NHRP key. Looks like IP NHRP network ID 78. Tunnel key 78 and tunnel source to show IP interface brief. Our tunnel source is this interface. Tunnel source and because it is DMVPN phase 2, I use tunnel mode GIU multi-point. And because it is a Spark, I use single command in either here. For single command, I have to use IP NHS, IP NHRP, NHS, then tunnel address of our hub, tunnel address, do shutdown. This is our tunnel address. Then I use MBMA Then use MBMA of physical address, tunnel source address of hub. It's just this interface tunnel source. This address. Tunnel source, and I use multicast at the end. Multicast. And at the end I have to compare routing on a R7. Create an IP route. A default route 000.0, and then use to show IP interface brief. Okay. IP route 0, then use this interface. One 56, 157. This is 7, and this for R5. It is 57, 5. Okay, I'm on R5. Show IP protocol for because I'm using OSPF of underlaid. This is OSPF on. Showdown pipe section for the OSPF. Okay. Config T the OSPF. Now use passive interface. This interface to show IP interface brief. Passive interface, this one. And specify this network. Network 156. One 57 and 5. Yeah, see, that's it. This is for routing backward toward R7. But this is we don't have protocol routing protocol adjacency, but we study with tolerance to ensure that we should be two tunnel imports. This is this part. This part. Okay. Well, let's verify our DMVPN is working, because 7 is up. If I to show DMVPN, and it is up, and it is dynamic, it is up, and it is up. This is our MBMA address, and this is our tunnel address. On the spoke, do show DMVPN, and it is up, and it is working. It is static. On 8, do show DMVPN. It is static. This is single. Our Comcast spoke with single NHRP command instead of these 3 commands. This command is working with it. Okay, on our 7, let's verify ping, because the DMVPN is on the VRF. I have to use VRF command, ping VRF, DMVPN VRF name DMVPN, and specify 156.192.71, which is working, and 78.8, 78 and 8. This is working either. Okay, that's it. It was DMVPN. I'll come with DMVPN phase 2, and then I'll create VRF. So I create VRF, then I'll move DMVPN into VRF. Then configure DMVPN phase 2 and check put static route for connectivity and so on. Okay, I hope you have enjoyed this video, and thank you for viewing. And Merry Christmas.